In this video, we're going to look at another example of turning a Riemann sum into an integral. So what we have here is the limit n goes to infinity, summation I goes from 1 to n, log of 1 plus I times e plus 1 over n times e plus 1 over n. We want to transform this to a definite integral with a equals minus 1. That means the lower limit is going to be minus 1. So you can see that's going to be a challenge because we don't have minus 1 showing up inside the brackets. So let's start with the definition of the right-hand Riemann sum formula. That's limit n goes to infinity, I goes from 1 to n, f of a plus I times b minus a over n times b minus a over n is equal to integral a to b f of x dx. This part here is xi. This is delta x. Alright, so xi is equal to a plus I times b minus a over n. So we know that a is negative 1. Let's rewrite this as xi is negative 1 plus I times b minus 1 over n. And that gives us negative 1 plus I times b plus 1 over n. The tricky part here is to rewrite log of 1 plus I times e plus 1 over n in such a way that xi is inside the log function. Let's write that down. So our goal is to write log of 1 plus I times e plus 1 over n in such a way that xi equals negative 1 plus I times b plus 1 over n is inside the log function, inside here. So we have to do some algebraic manipulations. Alright, so let's rewrite log of 1 plus I times e plus 1 over n. We'll rewrite this as log of 2 plus negative 1 plus I times e plus 1 over n. Now this part here, negative 1 plus I times e plus 1 over n, that's xi. Alright, so we have xi is equal to negative 1 plus I times e plus 1 over n. F of xi, the functional value, is going to be log of 2 plus xi. So I ranges from 1 all the way to n. x1, plugging I equals 1, x1 is negative 1 plus e plus 1 over n. x2 is negative 1 plus 2 times e plus 1 over n. And xn, this is the last x value, xn is equal to negative 1 plus n times e plus 1 over n. Now you can clearly see that the n's cancel out, and if we simplify this, we're going to get negative 1 plus 1, so we're just going to get the negative 1's cancel out, we get e, and this is actually b, the upper limit of integration. So we have a equals negative 1. We have b is equal to e. And we develop the function f of x to be equal to log of 2 plus x. So we can now transform the right-hand Riemann sum into a definite integral. We were given this question, limit n goes to infinity, I goes from 1 to n, log of 1 plus I times e plus 1 over n times e plus 1 over n. We transform this into a definite integral. Negative 1 to e log of 2 plus x dx. So this part here is f of xi. That's the functional value. This part is delta x. The lower limit of integration is a equals -1. The upper limit is b is equal to e. This is the functional part in the definite integral. This is f of x, and this part is dx. The Riemann sum has been transformed into a definite integral. All right, let's look at a diagram for what we have. Basically, we have y is equal to log of 2 plus x, and the definite integral represents the shaded area in green that you see here. So this part here is the integral from -1 to e log of 2 plus x dx. All right, thanks.